Questions 21 through 25 on the 2012 Grade 9 Pascal Math Contest. A string has been cut into 4 pieces, all of different lengths. The length of each piece is 2 times the length of the next smaller piece. What fraction of the original string is the longest piece? So we have this big long string here, and it's cut in the way that each piece is getting smaller by a factor of a half, right? So you have the original piece, and then the next piece is, say, half the length. The next piece is half the length, and then the next piece is half the length, like that. So let's say that is our string. So we can label it, if this is 4x, then the next one is 2x. Then the next one is x, and the next one is x over 2, like that. A string has been cut into 4 pieces, all of different lengths. The length of each piece is 2 times the length of the next smaller piece. Or if you don't like fractions, you can use 8x, 4x, 2x, and just x. Probably a little bit easier. So what they're saying is, what fraction of the original string is the longest piece? Okay, well, the longest piece is 8x, and the original string is the sum of all those pieces. So 8x plus 4x plus 2x plus x, which is 15x. And this is the fraction that they want. And the x's cancel, and all you're left with is just 8 over 15. So number 21, the answer is A. 2 circles with equal radii intersect as shown. The area of the shaded region equals the sum of the areas of the 2 unshaded regions. If the area of the shaded region is 216 pi, what is the circumference of each circle? Let's label this. The shaded region I'll call S for shaded, and the unshaded regions I'll call U for unshaded. And what they're saying in the question is that the sum of the areas that are unshaded, so 2U, is equal to the shaded region in terms of the areas. So that's our first equation. But if you just look at one circle, like that one, for example, you'll notice that U plus S is the sum representing one circle. So that's pi r squared, area of one circle. And I think that is it, except for this part here, the area of the shaded region. So the area of the shaded region is 216 pi, so S is 216 pi. And I think that's enough to calculate the radius, and once we calculate the radius, we can figure out the circumference. Okay, so let's move with this. We will substitute this into this right here. So we have 2U is equal to S, so U is equal to S over 2. So that means this is S over 2 plus S is equal to pi r squared. So that means if I add this, this is going to be 3 over 2S is pi r squared. Now at this point, I'll substitute that 216. 3 over 2 times 216 pi is equal to pi r squared. Do a little bit of math here. Is that what? 108 times 3, so 324. 324, and the pi's cancel, and all you're left with is just r squared. So r is going to be the square root of 324, which is 18. So there we go, we got the radius. Now to find the circumference of the circle, circumference is equal to pi times the diameter. Diameter is equal to 2 times the radius. So pi times 2 times the radius, which is 18. And therefore that makes 36 pi. That is the circumference of each of those equal circles. So number 22, the answer is C. Mike has 2 containers. One container is a rectangular prism with width 2, length 4, and height 10. The other is a right cylinder with radius 1 and height 10. Both containers sit on a flat surface. Water has been poured into the 2 containers so that the height of the water in both containers is the same. If the combined volume of the water in the 2 containers is 80 centimeters cubed, then the height of the water in each container is closest to. Well, the height they're saying is the same. So if this is h from here to here, then this is also h from here to here. Okay. Now they're saying that the combined volume of the two containers is 80. So 80 is equal to the volume here and the volume there. So the volume in the first one is going to be length times width. So that's 2 times 4 times the height. The volume here is a little bit different. It's pi r squared times the height, like that. So this becomes 80 is equal to 8h plus pi r squared. Well, r is 1. That's given in the question, so this becomes 1 squared. So this now becomes 80 is equal to 8h plus pi h. Factor out the h and you get 8 plus pi is equal to 80. Isolate for h and you get 80 is equal 80 over 8 plus pi is equal to h. Get out your calculator. Pi is approximately 3.14, so if you add 8 to it, it becomes 11.14. And now you get out your calculator, and 80 divided by 11.14 is approximately 7.18. And therefore, the one that is closest in the answers is this guy right here, 7.2. So number 23, the answer is B. The smallest of the 9 consecutive integers is 2012. These 9 integers are placed in the circles to the right. The sum of the 3 integers along each of the 4 lines is the same. If this sum is as small as possible, what is the value of u? Our integers are 2012, 2013, all the way up until 2020. There's 9 of them. Now, these numbers are pretty big, right? So instead of having to deal with big numbers, let's use smaller numbers. So each of these adds a certain amount to the sums. So we'll just use 2012 as sort of our base and make that a 0. And then each of these will add 1, 2, 3, 4, and so on to the sums. And this will be a little bit easier because the numbers are so much smaller. And I will call the numbers in here A, B, C, like that, right? So all of these numbers, if I add them up, A plus B plus C plus D plus E plus F plus G plus H plus I, right? I'm using 9 of these because there's 9 numbers. Now, I don't know which order it is. I don't know which one is A, which one is B, which one is going to be here, which in my case, I'm using E to represent U. It doesn't really matter what letters you use. I just like using A, B, C. It makes it easier. So one thing I do know is the sum. If I add all of these guys up, the sum I know for sure will be the sum of 1 plus 2 plus 3 all the way up until 8. And that sum is 36. 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 is 36. Now, another thing they tell me in the question is that the sum of the 3 integers along each of the 4 lines is the same. So the sum of these guys equals the sum of these guys, and equals the sum of these guys, and equals the sum of these guys. So each time you have a set of 3 numbers, for example, if this is A, I'll just write it beside it, A, B, C, D, E, F, G, H, and I, the sums of those 3 are the same. So that basically means that A plus B plus C, these 3 guys, are equal in the terms of their sum to these 3 guys. And that means that equals C plus D plus E. And similarly, C plus D plus E is equal to E plus F plus G. And E plus F plus G is equal to G plus H plus I. Okay, so no tricks so far. Now what we want to do is add all these guys up, all of them. So let's put it all in one line. A plus B plus C plus C plus D plus E plus E plus F plus G plus H plus I. Now you say, well, what good is that going to do? How does that help me in any way? Well, this sum, we don't know. We actually weren't told in the question, what is that sum? They say the sum has to be the same, but what is the sum? Does it add up to 48? Does it add up to... I don't know. So because I don't know, I'll just call it S for sum. So each of these is equal to S. So if I add them all up, I have 4S, right? Because this was S, 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 and S. So far it's 4S. Now the good news is that when you add A plus B plus C plus D plus E plus F plus G plus H plus I, that is 36. So I can put 36 here. Now the only ones I didn't add was this guy, this E, and this G. So I've got to put that there. C plus E plus G. And this is 4S. And then isolating for C plus E plus G, I get 4S minus 36. Okay? 4S minus 36. Now C plus E plus G, I can factor out a 4 and get S minus 9. Okay, so at this point we got to talk about this. C plus E plus G is obviously some multiple of 4. Okay? So we have to think about it by looking at those numbers up there. Now, this sum, C plus E plus G, is obviously a multiple of 4. And the question says we want to make it as small as possible. So how can I make a sum that is a multiple of 4 and small as possible using these numbers up here? Well, the smallest multiple of 4 is 4. There you go. That's it. That's the smallest you can make it, and it also obviously is a multiple of 4. So C plus E plus G has got to be 4. So that means 4 is equal to 4 times S minus 9. Therefore, that is 1 is equal to S minus 9, and therefore S is equal to 10. So that means the sum is 10. Remember, they said the sum of 3 numbers has got to be 10. So we just figured out the sum is 10, according to, the notation I'm using. Not the original numbers, obviously. Those are obviously far greater than 10. Okay, but what is C plus E plus G individually? Those 3 numbers have to add up to 4. And this is my designation for those 3 numbers. How can I get 3 of those guys to add up to 4? The only way is if you have 0, 1, and 3, I think. Yeah, 0, 1, and 3. That's the only way you can get a sum of 4. All right. So I think so far I have enough. I think that's enough to solve this question. So now let's make that little diagram and start filling in what we can to make everything fit. All right, so A, B, C, D, E, and this is my U, remember, this is the one they want me to figure out. A, B, C, D, E, F, G, H, I. Okay, I got to fill all these in with these guys right here. But I've got some clues now. I know that C, E, and G are 0, 1, 3. I don't know the exact order, but I know they're 0, 1, and 3. And I know the sum is 10. Okay, so let's work with this. C is, I don't know what C is. I know it's either 0, 1, and 3. So let's just say it's 0. E, I don't know what is E. Is it 1 or 3? I don't know. So I'll try 1. Let's see what happens. If I have 0 and 1, these 3 have to add up to 10, right? That is the sum. But the only way that's possible is if D is 9. But there is no 9. Notice that. There's no 9. So obviously that scenario is no good. So E cannot be equal to 1. Okay, no problem. I'll keep C as 0, but if E is not 1, it obviously must be 3. And therefore these 3 guys have to total 10. Well, I can do that by making that a 7. Okay, so I've taken care of that one. that one, and that one. Well, I've already got the answer to my question, but let's just fill all this in. C is 0, E is 3, so G must be 1. Okay, that's 1. These three guys have to add up to 10, so that means F has to be a 6. Correct? And then the rest you can kind of just fill them in. These three have to add up to 10, so I and H has to add up to 9, so I can put 5 and 4. And then these three guys have to add up to 10, so there's only two numbers left, I guess. 2 and an 8, so there you go. I can put the 8 here and the 2 here. So this all matches. So my question, or my task was to figure out U, and I did. It's 3, but obviously it's not 3. We had used 3 to represent 2015. So 2015 is the answer to the question, and that is choice D. There are 4 people in a room. For every 2 people, there is a 50% chance that they are friends. 2 people are connected if they are friends, or a third person is friends with them both, or they have different friends who are friends of each other. What is the probability that every pair of people in this room is connected? We have 4 friends. I'll call them A, B, C, D. And there's the following pairs. We have A and B, A and C, A and D, B and C, B and D, and finally C and D. Those are the 6 possible pairings. And now we have to figure out if they are connected or not. And the best way to do this question is with diagrams. So I will explain all the diagrams. And we're going to make a little bit of a table here. The first table is going to involve whether or not they are all connected or not, and if so, how many friendships are involved. So hopefully this will become clear as I explain it. So the first question is, all connected? Yes or no? The next is the number of friendships. So let's start off with the most basic one, and I'm going to draw a diagram to illustrate it. So this doesn't have to be a work of art. So here we go. The first one is if you have all 6 friendships, meaning all of them are friends with each other. So all of these are basically friends. Now that can be illustrated really nicely in a diagram as follows. You make a little box like this, and each of these represents a friendship. So this is friend A, B, C, and D. If 2 people are friends, they will be connected to one another. So A and B are friends, and as you can see, there's a line between them. A and D are friends, there's a line between them. B and C, C and D, D and B, A and C, all of them have a connection. That shows that they're all friends. That's what this diagram hopefully is showing. So there's 6 friendships, and all of them have a line with each other. 1, 2, 3, 4, 5, 6 lines, 6 friendships. And are they connected? The answer is yes. They are connected. They satisfy at least one of these. Okay, so that is just kind of simply explaining it. Now, if you're still not convinced, I'll break it down a little bit further, one at a time. So first I'll start with the first one. If 2 people are friends, how can you be illustrating them in a diagram situation? Well, if 2 people are friends, you just draw a line between them. And let's say those 2 people are A and B. There you go. That takes care of this one for our diagram purposes. The next one is a third person is friends with both of them. So they're not friends. So you got a situation where you have A and B. They're not connected. There's no line between them. But there is a third friend that they're both friends with. So let's say it's C. So there will be a line from B to C and A to C. That is what this is describing, the second one. A third person is friends with both of them. C is friends with A, is friends with B. But B and A are not friends with each other. But it doesn't matter for our connection purposes. This is still qualifies as connection. It is in the definition here of being connected. The third scenario, they have different friends who are friends of each other. Okay, what does that look like in a diagram? Well, let's draw it. Here's A, B, C, and D. It looks like the following. A and B are not friends, but A is friends with D. B is friends with C, but D and C are friends. Okay, that takes care of the third guy. So anything that looks like that means that A and B are connected. So it's pretty obvious that this satisfies pretty much, this sole first one by itself. We don't even need to worry about anything else. Okay, so if that is clear, let's move on. Now we move on to the next scenario. The next scenario is where the number of friendships are 5. And what that basically means is that instead of 6 lines, 1, 2, 3, 4, 5, 6, we're only going to have 5 lines. So 1 line will be missing. And what that basically means is that out of the 6 lines, you choose only 5 of them. So let me repeat that. In the first diagram, you know how you had 6 lines, 1, 2, 3, 4, 5, and 6. We only want 5 friendships. So instead of 6 lines, we want 5 lines. So out of the 6 lines, I choose 5. This is what that means. 6 choose 5. And 6 choose 5 is 6 factorial over 6 minus 5 factorial over 5 factorial. And if you do the math, that just comes out to 6. Okay? So there's 6 ways of having a situation of only 5 friendships. Now, if you do that, are they all connected? Well, let's see. Let's draw a diagram and see. Diagram, I will draw and then I will explain it. So this is going to be our diagram. And I only want 5 lines. So far I've drawn 4. Here's a 5th line. Does this connect everybody? If they're connected, they will be joined in some way. You'll be able to get from one friend to the other friend somehow. Like for example, in the first one, because A and B are joined directly, you can get from A to B on that line. But in the second one, A and B are not joined, but you can get from A to B through C. In the third one, A and B are not joined, but you can get from A to B through D and then through C. So they are connected if you can get from any one to another one through some path. And you can get from A to D, you can get from A to B, you can get from A to C, and so on, right? I mean, this basically means that everything is connected. So the answer here is yes. So far, there was only one way of making that box. So that's 1. There's 6 ways of making a situation where you have only 5 sticks, 5 connections. So that's 6. Okay. Now, some of you might say, well, I know another way of drawing this diagram. What about if you had something like this? And then you drew the sticks like this, the 2 diagonals, but then you got rid of 1 stick like up here. That's a way of making 5 sticks, and you're absolutely right. If you came up with that way, that's definitely a way of doing it. In fact, there's 2 ways of making this box and 4 ways of making that box. So that's why the total is 6. Okay, so far so good. Let's move along. Now the next one is 4 friendships. So what that means is instead of 6 sticks, I want 4 sticks this time. In a very similar way, from 6 possible sticks, you would choose 4 this time. And that is 6 factorial over 6 minus 4 factorial all over 4 factorial. And when you do that math, you get 15. So we got more here. We got 15 ways of making a diagram that has only 4 sticks, and that represents 4 friendships. Now, are they all connected though, if you have 4 friendships? Well, let's see. Let's draw some possibilities. Let's draw this one here. That's 4 sticks. Are they all connected? Can you get from any one of these to the others? And the answer is sure you can. That's definitely a connection. How about another diagram that has 4 sticks? Something like this. 1 stick across the middle, like that, but then 1 stick removed from one of the sides. That's 4 sticks, right? 1, 2, 3, 4. Is this connected? A, B, C, D. And the answer is yes. You can get from any letter to any other letter with a path. If you want to get from A to C, you can. If you want to get from A to B, you can. So this is also connected. So I encourage you to kind of go through this on your own and convince yourself, just don't, take it at face value. So this is also a yes. Now we get into the stuff that is a little bit more trickier. Now, I want to just take a pause here and say that these 15, there's a few more diagrams. I'll let you do that. I want you to come up with the other diagrams, but I will guarantee you that all 15 of them will be able to show connections. And those other diagrams, you know what? I'm a nice guy. I'll give you a hint. There's another one that has basically the 2 diagonals, but then you're just removing 2 sides like that. That's 4 sticks, right? 1, 2, 3, 4. And then there's others as well. And like I said, I want you to do that instead of me having to spell everything out for you. Okay, now we get to the last 3. The last 3 are where the question really not necessarily becomes extremely difficult, but that's how you're going to arrive at the right answer. Now I'm going to do the last 2 first, which is number of friendships is going to be 3 and 2 and 2 and 1 and 0, right? Those are my possibilities. Well, with 0, what that means is that basically you have just 4 dots, A, B, C, and D, and there's no sticks. Like that. No sticks. So are they connected? Well, definitely not, right? But how many of these do you have? From 6 possible sticks, you choose 0. And 6 choose 0 as 1. But that doesn't need to be counted because they're not connected. How about if you have 1 friendship? 1 friendship is a very easy diagram to draw. It's A, B, C, D, and you just have 1 stick. So somewhere, is this connected? Well, no. D and C are not connected, and D and A are not connected. How do you do that? From 6 sticks, you choose 1. And there's 6 ways of doing that. But it's not connected. How about 2 friendships? 2 friendships, again, pretty easy to draw an example. A, B, C, D. I got to use 2 sticks. How about that? That and that. That's 2 sticks. Are they connected? No. A is not connected to D. C is not connected to B. How many of these? From 6, you chose 2 sticks. And 6 choose 2 is 15. Now we get to the heart of the question, which is 3. 3 friendships is what decides whether you're going to get this question right or wrong. 3 friendships, and I think I'm going to need a little bit more space, so I'll move it over, has 5 different scenarios, unfortunately. So I'll draw them out. We got this one, and then, well, obviously I'm going to have to edit these. Okay, so the first one is 3 sticks, like that. Now, are these connected? Well, you tell me. If this is A, this is B, this is C, and this is D, is everybody connected? Think about it and let me know. And the answer is yes, they are, right? Because you can get from A to D, A to C, A to B in any sort of path like that. So there's 4 of these guys. Now, what is the total? I didn't do that yet, right? 6, it's going to be from 6, choose 3, if I'm following the same pattern as all the other ones. And 6, choose 3 is equal to 20. So I have to figure out, of these 20, how many of them are going to have a yes. And then some of them are going to have a no. This is the only one that splits up into yes, no, which makes it kind of challenging. Okay, let's move forward. Let's go to the next one. The next one, I just do a box, but that's not what it looks like because obviously that's too many sticks. The next one, what I really meant to draw is this. 3 sticks like that. So this is A, B, C's out here all by itself, and then D. Are these connected? And I am certain that you by now will be able to figure out that no, this is not connected. Now, how many ways of making these? There's 4 ways of making something like this, right? So these 4 are not connected. So the ones that are connected, I will circle. Okay, now let's go to the last 3. The last one is going to have basically a scenario like this, where you draw that and you get rid of those 2. So that means you have now 3 sticks, correct? So this is A, this is B, this is C, and this is D. Is everybody connected here? And the answer is yes, they are. So here's another 4 that's connected. The second last one is going to look like this, but I can only have 3 sticks, so I've got to get rid of a few. Got to get rid of this one, and I'll get rid of this one. So it becomes sort of a Z pattern. And are the Z patterns connected? Well, let's see. A, B, C, D, and the answer is yes. So this gives me 4 more. And then the very last one, that one is going to look like this. You're going to have 2 diagonals, but I've got to get rid of one. Actually got to get rid of 3. I get rid of this one, and this one. There you go. So it becomes sort of an X with a hat. And let's just label this. So this is A, B, C, and D. Are these connected? And the answer is yes. So of these 20, the only ones that were connected are this 4, this 4, this 4, and that 4. So 16 of them are yes. And this guy is a no. All right, so that's what I'm going to circle. So now what we have to do is count up all the yeses and then divide by the total. So I think I can do that. Let's just do it here, keep myself on the same page. So in any probability question, the denominator is the total. So what's my total, first of all? Well, I got 1, 6, 15, 20, 15, 6, and 1. Those are my total cases. When you add that up, you get 64. So that's my denominator. Numerator is the yeses. So this was a yes, that's 1. This was a yes, that's 6, we're up to 7. This was a yes, that's 15, we're up to 22. This one was a yes, 16. So now we're up to 38. And that's it, right? Yeah, that's it. Because everything else was a no. This is no, this is no, this is no, this is no. The 38 is my numerator. And that's the answer, 38 over 64. I think they've lowered it to lowest terms, 19 over 32. So let's go back, 19 over 32. For number 25 would be choice D.